Hello everyone, welcome to Homework Help. You can support the channel by becoming a member using the join button. In this video, we'll solve this problem using implicit differentiation. As per the problem, equation 5x squared minus 6xy plus 5y squared equals 16 represents an ellipse. Determine 2 points on this ellipse at which the tangent is horizontal. As you may know, tangent is a straight line. A horizontal straight line has a slope equal to 0. So we have to find points on this ellipse at which the slope of the tangent line is 0. Slope of a tangent line to this ellipse is equal to dy over dx for the equation of this ellipse. So the first step is to find dy over dx for this equation. Let's start by writing the given equation. We have to find the derivative of this equation with respect to x. The first term is 5x squared. 5 is the coefficient of the term. It's a constant, so it will stay as it is. The derivative of x squared with respect to x as per the power rule is 2x. In the second term, negative 6 is the coefficient of the term. It's a constant, so it will stay as it is. xy is made up of two functions, x and y. They are being multiplied, so we have to use product rule to find the derivative. As per the product rule, we start with the derivative of the first function. The derivative of x with respect to x is 1 times the second function y plus the first function x times the derivative of the second function. The derivative of y with respect to x is dy over dx. In the third term, 5 is the coefficient. It's a constant, so it will stay as it is. We have to use chain rule to find the derivative of y squared with respect to x. The inner function is y, the outer function is the exponent 2. As per chain rule, we start with the derivative of the outer function. We have to use power rule. We move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function. The derivative of y with respect to x is dy over dx. On the right side, 16 is a constant, so its derivative is equal to 0. This is the derivative of the given equation. Now we can simplify this equation and isolate dy over dx. 5 times 2x is 10x. We can distribute negative 6 into the parentheses. Negative 6 times 1 times y is negative 6y. Negative 6 times x is negative 6x. 5 times 2 is 10. The exponent on y is 1. Y to the power 1 is equal to just y. Next, we can move the terms 10x and negative 6y to the right side of the equation. That will change their signs. We keep the dy over dx terms on the left side of the equation. Next, we can factor out dy over dx from both terms on the left side. Next, we can divide both sides by negative 6x plus 10y to isolate dy over dx on the left side. So dy over dx is equal to 6y minus 10x over negative 6x plus 10y. As we discussed earlier, A horizontal tangent has slope equal to 0. dy over dx represents slope of tangent line. So we should set this expression for dy over dx equal to 0. We can solve this equation by cross multiplying the denominator. 0 times negative 6x plus 10y is equal to 0. Next we can move negative 10x to the right side of the equation. It will become positive 10x. Next we can divide both sides by 6. I get y equals 10 over 6x. 10 over 6 can be reduced to 5 over 3. This is the value of y in terms of x. We have to find 2 points on this ellipse at which the tangent is horizontal. The points at which the tangent touches the ellipse also lie on the ellipse. So we can find the 2 points by subbing in y as 5 over 3x in the given equation of the ellipse and solving for x. So we get I replaced y with 5 over 3x. Negative 6 times 5 over 3 is equal to negative 10. X times x is x squared. Square of 5 over 3x is equal to 25 over 9 x squared. 5x squared minus 10x squared is equal to negative 5x squared. 5 times 25 over 9x squared is equal to 125 over 9 x squared. We can add negative 5x squared and 125 over 9x squared by finding a common denominator. The denominator of negative 5x squared is 1. The common denominator is 9. So we should multiply negative 5x squared over 1 by 9 in the numerator and denominator. Now we can add the fractions. Negative 45 plus 125 is equal to 80. Next we can cross multiply the 9. 16 times 9 is 144. Next we can divide both sides by 80. Next we can apply square root to both sides. We get plus and minus cases. Square root of 144 is 12. We can simplify square root of 80 as 4 times square root 5 because 80 is equal to 16 times 5 and square root of 16 is 4. So we get x equals plus minus 12 over 4 square root 5. We can reduce 4 and 12. I get x equals plus minus 3 over square root 5. We get two x values, one positive, one negative. We have to determine 2 points on the ellipse at which the tangent is horizontal. So we have to find the corresponding y values for these two x values. Let's start with the positive x value. We should sub in x equals 3 over square root 5 in the equation y equals 5 over 3x that we got by setting dy over dx equal to 0. We can cancel out the 3's. We can simplify this fraction by writing 5 as square root 5 times square root 5. We can cancel out a square root 5 from numerator and denominator. I get y equals square root 5. So the first point at which the tangent is horizontal to the given ellipse is 3 over square root 5, comma, square root 5. Now we can find the second point using x equals negative 3 over square root 5. We can sub in this value of x in the equation y equals 5 over 3x. We can cancel out the 3's. We can reduce this fraction to just negative square root 5. So the second point at which the tangent is horizontal is negative 3 over square root 5, comma, negative square root 5. This should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.